Hi everyone, welcome to this new video. In today's video, I'm going to talk about model inference. So far, we know how to do experiment tracking using MLflow, which means that we know how to log metrics, artifacts, parameters, and we track those values across different experiments, right, or runs. We also learned how to train the model and use the MLflow flavors to log and register the model in the model registry. We also learned how to use MLflow to evaluate classic machine learning models like classification and regression models. In the next couple of videos, I'm going to focus on deployment. And when we are talking about deployment, we are talking about making the model available for use. If we're going to talk about deployment, we need to talk about model inference, right? So there are two types of inference, or at least the most common cases are batch inference, sometimes called offline, and real-time inference, other times called online inference. So here in this slide, I have like some differences between these two approaches. For batch inference, we tend to process large volumes of data, like for example, thousands or maybe millions of rows, while for real-time inference, the predictions are done for one or maybe a few inputs. For batch inference, the latency is not a top priority. We can schedule like a weekly or maybe monthly job to get the predictions, right? And that job can last like hours to finish. On the other hand, for real-time inference, as the name indicates, right, because it's real-time, the low latency is a must-have, right? So we're going to have the prediction as soon as possible. Batch inference, as I mentioned before, runs on scheduled jobs, while real-time inference, in this case, the inference process is triggered by an external API request, which means that an user action trigger the event. Now, batch inference is optimized for throughput. This means optimized for amount of data. On the other hand, the real-time inference is optimized for latency and availability. Latency means that when I should have the response or the prediction as soon as possible, and availability means that zero or almost zero downtime. I want to have the model available most of the time if possible. And then here we have the last difference. For batch inference, we use stale or snapshot data, while the real-time inference use real-time features that are being generated also in real time, for example. Now let me talk a bit more about the online inference approach. Here I have a representation of a server, the communication between a server and multiple clients. A server is basically a machine or computer, right, that provides some resources. For this particular case, the machine learning model is a resource. Now here we can see multiple clients. Each client represents also a computer or a machine, right, that communicates to the server. The client could be also maybe a downstream application that needs the model somehow. Now the communication that you can see here, it's happening through a network. For example, it could be through the internet, or if you're running this in your local machine, the local network. Now, let's take a look at this client. This client is making a request to get some predictions. He sends data in the payload of the request. Now, the server loads the machine learning model, uses the data that is in the request to get the prediction, and sends the prediction in the response, right? And this could happen for multiple clients. Now, this is a very basic explanation of how this communication works. But for today's video, I'm going to show you how to build a local inference server using FastAPI, which is a popular framework that we use in Python to build APIs. So let me go to the Python environment. So here I have my Visual Studio Code. And if I go to examples, the folder examples, we can see Iris Inference Server. And here we have like a small application built with FastAPI. So let me show you the code, a high-level overview of the code. And we start with this init script, right? So here, the first method that we see is this load ML model. What we are doing here is basically using this class model loader to load the model before even starting to serve the endpoints. So this function is going to be used as a value for the parameter lifespan here in this FastAPI class, so that FastAPI can run this function before starting the server. Why are we doing this? Well, as I mentioned before, we want to have very low latency, right? And if we load the model every time that there is an incoming request, well, that's going to slow down the process, right? So it's better just to load the model once and have the model available for the request. So, okay, here we have the logic, right? We create an instance of this class, model loader, and then use the method load model to, well, load this iris classifier model, and the alias is production. Now let me show you this definition, this class definition. Here we have like a small class that I use to implement the loader logic. So we have this load model method, and what we are doing here is the first, as you can see here, it takes as parameters the name of the register model and the environment. Environment basically represents the alias that we are using to register the model. By default is production. So the first thing that we can see here in this method is that we do some validations. We validate that the environment is, let's say, allowed, and for this case I have all these aliases: production, staging, and development, which are like the typical environments that we use in a server, let's say. Now then we look for the register models. If there are no register models with that name and alias, well, we raise exception, right? Value error, because the model is not registered. So I will not talk about the training part because we did that before. But to run this code, it's important to have a model registered in the model registry. So what else do we have here? Okay, after all the validations are done, we define the model URI. We load the model because, and in this case, we are using scikit-learn flavor because this is a scikit-learn model. And then we save the model in a dictionary within this class, right? Now I have some, let's say, helper methods, get model, which is going to help me to get the model. Then I have these clear models, which is going to help me to basically clear the dictionary. Now, since the dictionary ML models is a class variable, the models are going to be available for all the instances of this class, basically. Now let me go back to the init. That was the load ML model function, which FastAPI is going to execute first thing before starting the server, right? So by the time that we have the endpoints available, the model is already loaded in memory. Then here I have this app.include router, and what I'm doing is basically to include a router that I am defining in somewhere else. Basically the router is Inference. This is not going to be like a tutorial about FastAPI, but the idea of this router is to separate the endpoints, to have some separation of concerns here. So if I go to Inference, we can see that it comes from this module, routers. So let me go there, routers. And here we are defining the API router Inference. Now using this object, we can define the endpoints. Now, in this case, I want to simulate the local server that MLflow provides, because the point of this video is to show you the difference between building the inference server with FastAPI and with MLflow. Now, MLflow provides 4 endpoints: health, ping, version, and invocations. And these endpoints are basically to retrieve or to know the status of the server, if everything is okay, right? And version is basically to return the MLflow version. And in invocations, I have the logic to process the input, right, the model input, and get the predictions. So here, within this invocation method, I am expecting an object called iris request, right? This iris request corresponds to a schema that I built using a Pydantic, right? So with Pydantic, I am implementing data validation step, right? Because before using the model, I want to be sure that the data is correct. So for this iris request, I am defining this data, right? The columns basically, the length of the sepal, the width, length, and width of the petal. So all these are numbers of floats, right? And that's what you can see here. They are basically fields. Now here I have some helper functions or methods, right? This one is to get the values in a list, and this one is to get the column names or the feature names. Now, if I go to my routers, you can see that here I am defining a schema for the response as well, right? So if I go to schemas, you can see the definition here. The schemas is going to contain the species and the confidence, or the probability that we get when we use the predict probat method, right? And here we are just doing some mapping, right? Because remember that the predict method returns an integer, 0, 1, or 2. But I want to know the species, Setosa, versicolor, or virginica. So what I'm doing here is basically given that this value, species ID, I'm going to map that to the name of the species, basically. Now, this is basically the schema validation that I'm doing here. Now, if I go to routers, let me show you the logic. So when a client make a request to this endpoint, I'm going to get this object populated with the features, right? I use this model dump method to get a dictionary representation of the features. Then I use my class model loader.getModel. Now remember that when I start the server, this function is going to be executed. The global dictionary is going to be populated with this model, right? Which means that by the time that I'm calling this method, I should have this iris classifier model available in my dictionary of models. Anyways, if the model is not available, I'm going to send this response, right? Basically a message, an error message saying that the model is not found. Now, if the model is found, I'm going to proceed with getting the value of the features, right? Then use the predict method that the model provides, right? And the predict proba to get the confidence, right? Then I'm building the response of the model, which is the species and the confidence. So this is basically all the code for the FastAPI. Now I'm going to run this locally, right? So let me go to examples, and then here I can use something like poetry, run FastAPI dep, and I'm going to specify iris inference server, which is the folder in which I have my init script, right? So FastAPI is going to look for this script and this application. Okay, it's starting the server, starting development server, is looking for the application in this script. Here, setting MLflow tracking URI, it's trying to load the model right now. And finally, application started complete. Now I'm going to go to this location in the browser. And here we have the documentation and the UI that FastAPI offers, right? So I have the health endpoint. Let me try this out. Execute. Health is doing nothing basically. So this is just like to check the status of the server, that everything is up and running. And the version, let's check the MLflow version that we are using here. 2.20. Wow. Right now it's like MLflow 3.0, so I'm a bit behind. Okay, anyways, here we have the invocations endpoint, right? We can use this to get predictions. So here we have like the columns, right? Let's try with this value. If I execute this method, I can see the prediction, right? Species, setosa, confidence 1. Let me try with something different. Let's say this random value. Let's see if we have something different. Okay, yes, it looks like we got something different, right? Now let's try the validations. Let's say that instead of a number, I send a string here, right? Let's see what happens. If I execute this, it says error, unprocessable entity, right? And you can see here the details. It says the input should be a valid number, unable to parse a string as a number. So that's the beauty of Pydantic, right? The validations that we're having here. Well, the integration of Pydantic and FastAPI, basically. Okay, so we have this validation here, right? Let's say that we make a mistake and we pass the wrong feature name, right? If I try this, again, error. It says missing field, right? It's expecting this field. It's because it's a required field. So here we're having all the validations necessary to score the machine learning model. So we have again the prediction. So, well, that's all for this video. In the next video, I'm going to show you how to do this with a single command in MLflow. But for now, that's all for this video. Thanks for watching it and see you next time.